We will use outer-inner to simplify complex fractions. What is a complex fraction? A complex fraction is a fraction divided by another fraction. And here I have 4 examples of various complex fractions. Don't panic, you'll learn to do these before the semester's out. Here's the rule for outer-inner. It says that if I have A divided by B, that whole thing divided by C over D, then it has outer and inner components. The outers are in red, A and D, and they're going to be multiplied and put on top of the quotient we're going to get. And the inners are B and C, and they will become multipliers in the denominator of the quotient. So let's look at an example. But before we do, I'm going to show you the way you probably learned to do division of fractions. Here you were probably taught to take 2/3 divided by 5/2 and write it as 2/3 with a division symbol divided by 5/2. And then you were told to take the first fraction, keep it the same, change the operation to multiplication, and multiply by the reciprocal of the second fraction, which is 2/5, and perform the multiplication of fractions and get 4/15. Now I'm going to show you how, using outer-inner, you can get the same answer. Here's the same problem. The outers are in the green, 2 times 2 across the top. The inners are in purple, 3 times 5 across the bottom. Finish the multiplication, 4/15. Same answer. Here's another example, one with a negative fraction in it, but it still works the same. My outers are -3 times 5, that goes up in the numerator, 4 times 2, that goes in the denominator, and I get -15 all over 8. Or you can do it in the method you were taught in grammar school, which is to write it again as -3/4 divided by 2/5, keep the -3/4, change the division to multiplication, multiply by its reciprocal, 5/2, and do the multiplication. -3 times 5 gives you -15. 4 times 2 gives you gives you 8. This is what we're working towards. This looks a little complicated, but it's really not as complicated as it seems. You just need to be able to identify the parts that are here. And remember, in outer-inner, you have a fraction divided by a fraction. So here is my one fraction, and here is my other fraction. So my outer parts are x minus 2 and 2. X minus 2 times 2 in the numerator. And my inner parts are the 3 and the quantity x minus 1, x minus 2. That goes in the denominator. And notice that I have an x minus 2 and an x minus 2 in the top and bottom, and they cancel, leaving me with just 2 over 3 times x minus 1. Or perhaps you will want to do a problem that requires both whip, whip, whap and outer-inner. Here in the purple, I have a possible whip, whip, whap part in the numerator, and maybe a possible outer-inner in the denominator. Let's see. So, we're going to take the problem one piece at a time. I'll begin with the numerator. I rewrite 2x minus x over 3 as 2x plus a negative x over 3. And now I can perform whip, whip, whap. 2 times 3 plus x times a minus x all over x times 3. Do a little simplification. 2 times 3 is 6. X times a minus x is minus x squared. X times 3 can also be written as 3x. And I just simply got rid of the plus sign and called it 6 minus x squared over 3x. Now that's my numerator. And I'm going to work with that over here. But before I do that, I need to go back to the denominator and see if I can simplify it. In the denominator, I have 1 over x minus 1 over 1, and the first question you might ask is, who belongs to who and who's dividing who? Well, this larger division bar right here indicates the prominent division, or the primary, and this smaller one indicates the secondary. So this really says 1 divided by this guy, x minus 1 over x. But in order to use outer inner, you must have it in the form a over b divided by c over d. So we can make 1 into 1 over 1 pretty easily. And now we have an outer part and an outer part, 1 times 1, an inner part and another inner part, 1 times the quantity x minus 1. Simplify it and we have 1 over x minus 1. Well, we're not done because we still haven't finished the problem, but we've simplified it quite a bit. So now the 1 over x minus 1 comes over here. And this is what we're going to be dealing with now. But it's set up to do outer inner, because here's an outer piece and here's an outer piece. I write quantity 6 minus x squared times x minus 1, and my inner piece is 3x times 1, 3x times 1, and I simply move it over here, simplifying it, because 3x times 1 is just 3x, and I don't need to multiply these out. You can if you want, but why?